Right, so as we start into this module and look at basic Ethernet, I want to touch on a couple of things to help you understand the stuff you're reading about in the textbook. We're going to be talking about 10 base T Ethernet, and then go into 100 base T, and then on into other technologies that are faster speeds. You should know that Ethernet is a contention-based technology. That simply means that first come, first served. The traffic on an Ethernet network, or the data that's being carried, can be broken into two broad categories. That doesn't mean all traffic. This is just the generalization. Roughly 50% of the traffic, if you could look at every piece of data, is a broadcast kind of message. And a broadcast is a one node sending to all of the nodes that are part of that part of that broadcast domain. So it's a one to everyone. And the other 50% of the traffic is unicast. Unicast is a one-to-one transmission. So you can break the traffic down into a 50-50 type thing. All right, so what is the traffic on an Ethernet network? Well, traffic is simply chunks of data, and we call those chunks of data a frame. Now, if I can get in close enough here, you have this in your book, but let's take a look at what a frame really is. A frame is a chunk of data, starting with the preamble, which is 8 bytes long, the destination and source address, and you can see it's 6 bytes. And 6 times 8 is 48. And if you are thinking to yourself, hey, that's the MAC address, then you're absolutely correct. And then the next field is the type field, what type of Ethernet frame it is. And then you have the actual information. And then at the end you have a trailer. Remember, at the data link layer, besides the header, you also have a trailer, and that provides the complete encapsulation of the information. Now, if you don't have at least 46 bytes of data, then the system will add more to get it up to 46, because there is a minimum and a maximum that you can have for a frame. All right, now more stuff to think about for Ethernet. The topology is star, and that's what they started off as, but they quickly grew into extended stars and then mesh networks and so forth. And then the last thing to consider is the access method, which is CSMACD, carrier sense multiple access with collision detection. Now here's a chart, or a flow chart, I should say, that shows you the CSMA activity, right? CSMACD. And you start in the top left-hand corner. And the first thing that happens is a station that wants to transmit will first of all try to detect any ongoing transmission, which would be activity. If it detects nothing is going on, then it will start to transmit. And then it will try to detect a collision, and if it does, it will stop transmitting. It will perform the jam procedure, and then it will wait and go back into the listening mode. If it detects activity initially, it goes into a wait mode, and then goes back and listens for activity. So from the flow chart, you can pretty much see how CSMACD takes place. It allows different nodes to get access to the network, send their frames, and make the magic happen. All right, so with this, I hope that you have a basic intro to Ethernet.